In 1924, we thought the Milky Way was the entire universe, until Edwin Hubble proved us wrong. What looked like a faint blur in the night sky was actually the Andromeda Galaxy, bigger than our own and filled with over 1 trillion stars. That discovery shattered our place in the cosmos. And here's what most don't realize. Andromeda is coming. Slowly, silently, it's moving toward us, set to collide with our galaxy in a few billion years. So, how does it feel knowing the universe isn't just vast? It's in motion, and we're part of something far more epic than we imagined. Meet our galactic neighbor. There's a silent wanderer hanging in our night sky, so vast, so close, yet so quietly overlooked. You might have seen it without realizing, a faint smudge in the dark, barely noticeable to the naked eye. But that humble smudge, it's the Andromeda Galaxy, the closest spiral galaxy to our own Milky Way. And it's not just a neighbor, it's a giant, bigger and more massive than our own galaxy. If you could travel at the speed of light, it would still take you over 2.5 million years to get there. That's not just distance, it's a time capsule. The light we see from Andromeda tonight actually left it during the time early humans were first learning to use tools. It's like looking through a cosmic window into the deep past. But Andromeda isn't just a relic, it's a message. A reminder that even in the vastness of the cosmos, we're not alone in the dark. Galaxies like ours aren't solitary islands floating aimlessly. We're part of a larger galactic family. And Andromeda? It's our sibling, slowly drifting closer every second. Isn't it wild that while we scroll through phones and binge-watch shows, entire galaxies are inching toward one another for a cosmic reunion? Size, distance, and visibility. Let's break down just how massive our neighbor really is. Andromeda spans about 220,000 light-years across. That's nearly double the size of the Milky Way. And within that spiraling colossus are over 1 trillion stars. Yes, trillion, with untold numbers of planets orbiting around them. Some astronomers even suggest it might contain twice the stars we have. And here's the incredible part. On a clear night, far away from city lights, you can actually see Andromeda with your own eyes. No telescope, no binoculars, just you in the night sky. What you're seeing, though faint, is the furthest object visible to the naked human eye. That fact alone makes it special, because without any tech or training, you're literally staring across time and space. Think about that. You're standing on a tiny planet, looking out across 2.5 million light-years. The light hitting your retina tonight left Andromeda when early ancestors of modern humans were first learning to stand upright. You're not just stargazing, you're time-traveling. It's not just a galaxy, it's a reminder that the universe is much, much bigger than our day-to-day worries. Structure and composition. You might think galaxies all look the same, a bunch of stars swirling in space, but Andromeda? It's got some serious style. This majestic spiral galaxy has a glowing central bulge, 2 massive arms that twist outward, and hundreds of smaller star clusters sprinkled throughout like cosmic confetti. Scientists estimate it has over 1 trillion stars, compared to the Milky Way's 200 to 400 billion. That's 5 times more stars lighting up its structure. It even has satellite galaxies of its own, just like we have the Magellanic Clouds. Andromeda's arms aren't just starry decoration. They contain countless planetary systems, star-forming nebulae, and possibly even black holes hiding deep inside. What's fascinating is that it isn't chaotic, it's organized beauty on a scale we can barely comprehend. Even the dust lanes, those darker regions cutting across the spiral arms, are essential. They're not voids, but rich with gas that could one day form new stars. It's like Andromeda is a living, breathing structure constantly creating, evolving, changing. From its bright, dense core to the wispy edges of its arms, every part of it tells a story billions of years old. History of discovery. Long before we knew what a galaxy even was, Andromeda had already made an impression. Ancient Persian astronomers wrote about a little cloud in the sky, one that didn't twinkle like the stars. That cloud was Andromeda, and for centuries that's all anyone thought it was, a fuzzy patch in our own galaxy. Then came 1924. Edwin Hubble, yes, the guy the telescope's named after, changed everything. Using a powerful telescope, he found variable stars inside Andromeda and measured their distance. What he discovered shocked the world. Andromeda wasn't inside the Milky Way at all. It was its own separate galaxy, millions of light-years away. This moment shattered our idea of the universe. Suddenly, the Milky Way wasn't the universe, it was just one galaxy in a cosmos full of them. Andromeda opened the floodgates to modern astronomy. It was the first galaxy we truly understood as being independent of our own, and it forever expanded our cosmic horizon. That fuzzy smudge? It forced us to rewrite everything we thought we knew, and in doing so, it made the universe feel both infinitely bigger and far more connected. Collision course with the Milky Way. Every second Andromeda is moving closer to us, about 68 miles per second. That means with every heartbeat, the distance between our galaxies shrinks just a little more. It's not a maybe, it's a cosmic certainty. Scientists predict that in about 4 billion years Andromeda and the Milky Way will collide. Not like a violent explosion though. Because space is so vast and stars are so far apart, most will simply drift past one another, dancing through gravity's pull. It's more of a slow-motion ballet than a demolition derby. Over time, this celestial interaction will stretch, twist, and eventually merge both galaxies into a brand new formation, Milkomeda or Milkdromeda, as some astronomers playfully call it. Earth might survive, the sun might still shine, but the night sky will change forever. If future humans or civilizations exist then, they'll look up and see skies ablaze with stars from both galaxies. It's wild to think that something as stable and constant as our galaxy is part of a much bigger story, one that's still unfolding. Our peaceful skies today? They're the calm before a magnificent billion-year storm. Possibility of life. What if we're not alone, even just one galaxy over? With over 1 trillion stars and potentially billions of planets, Andromeda might hold secrets we can't yet fathom. Some of those planets could sit in the habitable zone, the sweet spot where liquid water can exist. That's the first ingredient for life as we know it. And since Andromeda is older than the Milky Way, some of its stars have had a head start by billions of years. What if intelligent life evolved there long before humans ever lit their first fire? Or what if ancient civilizations rose and fell before we ever looked up? While we haven't found signs of life in Andromeda, we're only beginning to understand its vastness. Most of its planets are too far for us to study in detail, yet. But advancements in telescopes and interstellar tech could one day let us glimpse alien skies, distant oceans, or even civilizations waving back. Right now, it's all questions and wonder, but maybe that's the point. The search for life in Andromeda isn't just about science, it's about connection, about asking, are we really the only ones out here? The hidden skeleton of Andromeda. You can't see it, you can't touch it, but it holds everything together. Nearly 90% of Andromeda's mass is invisible, made of something scientists call dark matter. It doesn't emit light, it doesn't reflect it, and yet, it's everywhere, acting like a hidden skeleton that binds galaxies. We only know it exists because of what it does. Andromeda's stars rotate at speeds that shouldn't be possible if only visible matter existed. By all logic, those outer stars should have flung off into deep space by now, but they haven't. Something is keeping them tethered, and that something is dark matter. It's like a silent architect, shaping galaxies from the shadows. And here's what's even more fascinating. Andromeda's dark matter halo stretches far beyond its glowing arms, like an invisible shield. It might even be interacting with the Milky Way's own dark matter cloud as we speak. The more we study Andromeda, the more we realize it's not just about stars and light, it's about the unseen forces that define the universe. Think about that. Most of what exists in our closest neighbor is something we still don't understand. A cosmic transformation. As we continue to observe Andromeda, one question persists. What will happen to both galaxies once they collide? While this event is billions of years away, the concept of such a cosmic transformation is deeply intriguing. Astronomers believe that the merging of the Milky Way and Andromeda will not result in a catastrophic collision of stars. After all, space is vast, and stars are spaced far apart. Instead, it will be a slow dance of gravitational forces, causing the two galaxies to slowly stretch, twist, and eventually fuse together into a brand new galaxy. Some suggest that this new galaxy could be called Milkomeda or Milkdromeda. However, as the galaxies collide, their supermassive black holes will likely converge as well, sparking a new and intense period of star formation in the aftermath. With this collision, new stellar structures will form, possibly creating an even more magnificent cosmic display in the future sky. For life on Earth, this event may not pose any immediate threat, as the collision will unfold over millions of years. But what about future civilizations? Will they witness the collision in real time, perhaps from a planet in the new galaxy? The possibilities are endless, and the collision between Andromeda and the Milky Way is sure to redefine the very nature of the universe as we know it. It's a reminder that even the most stable elements in the cosmos are subject to change, and the future of the universe is written in the stars. And there you have it, the Andromeda Galaxy, a giant in our cosmic neighborhood with mysteries that continue to fascinate astronomers. Isn't it amazing to think about the vastness of the universe right next door? If you're as amazed by the wonders of space as we are, make sure to keep exploring with us. And if you love discovering the secrets of the universe, don't forget to like, subscribe, and hit the bell icon for more adventures with space facts. Did you know that La Niña events can reshape weather patterns across the entire globe, affecting millions of lives in ways you might never expect? From fierce storms to intense droughts, this natural climate phenomenon holds enormous power over our planet's future. Understanding La Niña isn't just about weather forecasts, it's about unlocking the secrets of Earth's climate engine. When La Niña strikes, the world doesn't just change, it transforms. What is La Niña and how does it form? Have you ever noticed how the weather sometimes seems to have a mind of its own? Unexpected storms, unusual droughts, or shifts in temperature that don't quite add up? That's often the Earth's way of reacting to a powerful climate pattern called La Niña. La Niña is essentially the cool sibling of El Niño, both part of a climate phenomenon known as the El Niño Southern Oscillation, or ENSO. It happens when the surface waters in the central and eastern Pacific Ocean become cooler than usual for several months. This cooling is caused by stronger than normal trade winds pushing warm surface water westward, allowing cold water from the deep ocean to rise up near the coast of South America. This shift in ocean temperature doesn't just stay put, it sends ripples through the atmosphere, changing weather patterns across the globe. La Niña events typically last from 9 months to 2 years and can repeat every 2 to 7 years. Because the oceans and atmosphere are so tightly connected, these changes in the Pacific can influence rainfall, temperature, and storm activity thousands of miles away. Understanding La Niña is like unlocking a key to predicting some of the most extreme weather events on Earth. Impact on global weather patterns. La Niña doesn't just mess with the weather locally, it rewires the planet's entire atmospheric system. When the Pacific Ocean cools down during La Niña, it shifts the jet streams. Those fast-moving air currents high in the atmosphere that steer storms and weather systems. This shift can cause some regions to experience colder, wetter winters, while others might face hotter, drier conditions. For example, during a La Niña event, the northern United States and Canada often get colder winters with more snow, while the southern United States tends to be warmer and drier. Across the globe, countries in Southeast Asia and Australia usually see heavier rainfall, sometimes leading to floods, while parts of South America, like Peru, often experience drought. These changes happen because La Niña alters the balance of heat and moisture in the atmosphere, changing how air moves around the planet. The result? A domino effect of weather changes that can disrupt agriculture, water supplies, and even energy demand. The global reach of La Niña is a reminder that what happens in one part of the world's oceans can have far-reaching consequences for millions of people everywhere. Effects on rainfall and droughts. When La Niña kicks in, it's like the planet's weather gets a major remix. Some places get drenched, while others barely see a drop of rain. This isn't random, it's all about how La Niña shifts moisture around the globe. In regions like Southeast Asia and Northern Australia, La Niña often brings heavy rains and flooding. These downpours can replenish water supplies and boost crops, but also cause serious damage when rivers overflow and landslides occur. Meanwhile, places like the southwestern United States and parts of South America often face the opposite drought. The lack of rain can stress farmers, dry up reservoirs, and increase wildfire risks. This push and pull of wet and dry conditions happens because La Niña changes wind patterns and ocean temperatures, which in turn influence where clouds form and where storms track. The result? Some communities might celebrate a season of abundant rain, while others brace for water shortages. Understanding these patterns helps governments and farmers prepare better, but the unpredictability still keeps everyone on their toes. Influence on hurricanes and tropical storms. La Niña doesn't just affect rain and drought, it also turbocharges hurricane activity, especially in the Atlantic Ocean. During La Niña years, the Atlantic tends to see more hurricanes and tropical storms, sometimes with greater intensity. Why? Because La Niña cools the surface waters of the eastern and central Pacific, which reduces wind shear over the Atlantic. Wind shear is like nature's way of breaking up storms before they get too strong. With less of it, hurricanes can grow bigger and last longer. This means coastal areas in the United States, the Caribbean, and parts of Central America face a higher risk of powerful storms. Meanwhile, the Pacific often experiences fewer hurricanes during La Niña, as the cooler waters and stronger winds suppress storm formation there. This seesaw effect between ocean basins shows just how interconnected Earth's climate system is. For communities in hurricane-prone areas, La Niña years are a time to be extra vigilant, prepare emergency plans, and stay informed because honestly, the stakes are higher when the storms come knocking more often. Impact on agriculture and food security. When La Niña arrives, it's like the Earth's thermostat and watering system get out of sync, and farmers around the world feel the impact firsthand. Crops depend heavily on predictable weather. Too much rain can drown plants, while too little can starve them of water. La Niña's shifts in rainfall and temperature can cause both extremes depending on where you are. For example, in places like Australia and Southeast Asia, heavier rains can boost rice and sugarcane yields, but flooding can also ruin fields and delay planting. Meanwhile, drought-stricken areas like parts of South America and the southern United States might see their corn, soybean, and wheat harvests shrink. These disruptions ripple through the food supply chain, pushing prices up and threatening food security for vulnerable populations. Farmers must adapt quickly, sometimes changing planting schedules or switching crops. La Niña's unpredictable nature means that communities reliant on agriculture often face uncertainty, making it harder to plan for the future. The stakes are high because food isn't just about crops, it's about livelihoods, economies, and survival. Effects on marine life and fisheries. La Niña's chill in the Pacific Ocean doesn't just affect the weather, it sends shockwaves through marine ecosystems too. Cooler surface waters and stronger ocean currents during La Niña change, where nutrients rise from the deep, creating feeding hotspots for fish and other sea life. This can be great news for fisheries in some regions, boosting fish populations and catches. For example, the cold, nutrient-rich waters off the coast of South America often support thriving fisheries during La Niña years, but it's not all positive. The altered ocean conditions can disrupt breeding cycles and migration patterns for many marine species. Some fish may move to cooler waters, forcing fishermen to travel farther or adapt to different species. Coral reefs, sensitive to temperature changes, can also be stressed, affecting the entire marine food web. These shifts impact not only ecosystems, but also the millions of people worldwide who depend on fishing for food and income. La Niña reminds us that the ocean and atmosphere are deeply connected, and changes in one ripple through the other in surprising ways. Long-term climate and environmental consequences. La Niña isn't just a short-term weather event, it's a powerful player in the long game of Earth's climate. When La Niña events happen repeatedly over years or decades, they can leave lasting marks on ecosystems, weather patterns, and even human societies. These cycles influence drought frequency, wildfire risks, and the health of forests and wetlands. For example, extended La Niña periods can dry out some regions, making wildfires more likely and stressing plants and animals that rely on steady rainfall. Meanwhile, other areas might see repeated flooding that reshapes landscapes and disrupts communities. On a larger scale, La Niña interacts with global warming, sometimes masking or amplifying temperature trends. This makes predicting future climate conditions even more challenging. For people, these long-term shifts mean adapting how we manage water, agriculture, and disaster preparedness. Scientists study La Niña closely because understanding its patterns helps us prepare for a future where extreme weather might become the norm. It's a reminder that Earth's climate is a complex system, where ocean and atmosphere dance together, shaping life in ways we're still discovering. Thanks for joining us on Space Facts today. If you found this deep dive into La Niña fascinating, don't forget to hit that subscribe button and ring the bell icon so you never miss an update on the amazing forces shaping our planet and beyond. We'd love to hear your thoughts. Drop a comment below and tell us how La Niña has affected your area or what topic you want us to explore next. Stay curious, and we'll see you in the next video. The Sun is so massive that it contains 99.8% of all the mass in our solar system, dwarfing every planet, including Earth. Yet Earth's water, covering 71% of its surface, holds the key to life as we know it. Here's a striking thought. If we poured all of Earth's water onto the Sun, it would barely make a ripple. Did you know just how tiny our planet's water is compared to the vastness of the Sun? Let's uncover what really happens in this cosmic showdown. The sheer volume of Earth's water. Earth's water is staggering in scale. About 1.4 billion cubic kilometers of it spread across oceans, rivers, lakes, and underground reservoirs. This vast quantity covers around 71% of our planet's surface, shaping climates, ecosystems, and life itself. But when you compare this to the Sun, the numbers tell a different story. The Sun is a colossal ball of plasma with a volume roughly 1.4 million times greater than Earth's. So even if we could somehow gather every drop of water on Earth and pour it onto the Sun, it would be like adding a single teaspoon to an Olympic-sized swimming pool. This comparison highlights just how immense the sun truly is. While Earth's water seems endless to us, it's practically negligible on a cosmic scale. Understanding this contrast not only puts our planet's resources into perspective but also sparks curiosity about how such a relatively tiny amount of water would behave in the sun's extreme environment. This sets the stage for a fascinating exploration of what would really happen if Earth's water met the fiery surface of our nearest star. The sun's enormous scale. The sun isn't just big, it's unimaginably massive. When you hear that the sun's volume is about 1.4 million times that of Earth, it's hard to grasp what that really means. To put it simply, if Earth were the size of a small marble, the sun would be a gigantic beach ball towering over it. This vast difference in scale means that even the entirety of Earth's water, which feels endless to us, is just a tiny speck compared to the sun's sheer size. The sun's enormous volume is made up of scorching hot plasma, a state of matter so extreme it's unlike anything we experience on Earth. This immense size and energy output allow the sun to sustain nuclear fusion, the process that powers its light and heat. So when thinking about pouring all Earth's water onto the sun, it's like trying to fill a massive ocean with a single bucket of water. The sun's colossal scale means that this water would barely make a dent, swallowed instantly by the star's overwhelming mass and energy. This contrast between Earth and the sun's size sets the stage for understanding why such a dramatic idea, pouring all our planet's water onto the sun, would have surprisingly little impact on the star itself, even though it would be catastrophic for life here on Earth. What is the sun made of? The sun is not just a giant ball of fire, it's a swirling mass of plasma, mostly hydrogen and helium, existing in a state that's completely alien to us. About 74% of the sun's composition is hydrogen, with helium making up roughly 24%, and the rest are trace elements. This plasma state means the sun's gases are so hot and energized that electrons are stripped from atoms, creating a soup of charged particles. Unlike the water we're familiar with on Earth, which is liquid and cool, the sun's surface temperature is around 5,500 degrees Celsius, and its core reaches an astonishing 15 million degrees Celsius. In this environment, water molecules can't survive. They would instantly break apart into hydrogen and oxygen atoms. This extreme heat and energy make the sun a nuclear fusion reactor, where hydrogen atoms fuse to form helium, releasing immense energy that powers life on Earth. So when thinking about pouring Earth's water onto the sun, it's important to remember that the sun isn't a solid surface or a cool body of water. It's a blazing, electrified plasmasphere where water can't exist in any familiar form. This fundamental difference in composition and state of matter explains why Earth's water would be completely transformed the moment it touched the sun's atmosphere, setting the stage for what happens next in this cosmic experiment. What happens to water near the sun? Well, water and the sun are a recipe for instant transformation. The moment any water from Earth approached the sun, it wouldn't stay liquid for even a fraction of a second. The sun's surface temperature is about 5,500 degrees Celsius, hot enough to vaporize water instantly. But it doesn't just evaporate like steam from a boiling kettle. The intense heat breaks water molecules apart into their basic elements, hydrogen and oxygen atoms. These atoms then become ionized, meaning they lose electrons and turn into charged particles, blending seamlessly into the sun's already roiling plasma. This process happens so quickly and violently that the water essentially disappears, losing all its original form. Instead of a splash or steam cloud, the water's atoms become part of the sun's fiery atmosphere, carried away by solar winds or absorbed deeper into the star. This extreme environment ensures that Earth's water would never accumulate or create any visible effect on the sun's surface. So, pouring all of Earth's water onto the sun wouldn't cause a dramatic explosion or change. It would be a silent, instantaneous absorption into the star's blazing furnace, highlighting just how hostile and powerful the sun truly is. Would the water affect the sun's composition? Adding all of Earth's water to the sun might sound like it could change the star's makeup, but in reality, it's barely a drop in the cosmic ocean. The sun's mass is about 330,000 times that of Earth, and its composition is overwhelmingly hydrogen and helium. When water, made of hydrogen and oxygen, arrives, it's such a tiny addition compared to the sun's massive volume that it won't noticeably shift the star's elemental balance. The hydrogen from water would simply blend into the sun's existing hydrogen supply, while the oxygen atoms would be quickly ionized and absorbed into the plasma. This means the fusion reactions that power the sun would continue unaffected, as they rely on hydrogen nuclei colliding under immense pressure and temperature in the core. The sun's immense energy output and gravity dwarf any influence Earth's water could have. So despite the dramatic idea of pouring all our planet's water onto the sun, it wouldn't alter the star's composition or behavior in any meaningful way. This highlights the incredible scale and power of the sun compared to our home planet, emphasizing how small Earth's resources are in the grand scheme of the cosmos. Could the oxygen from water cause any reaction? Oxygen might seem like a wild card when it comes to pouring Earth's water onto the sun, but it wouldn't cause any dramatic fireworks. Once water molecules break apart near the sun, oxygen atoms become ionized, stripped of their electrons, and merge into the sun's plasma environment. This plasma is already a chaotic mix of charged particles, so the oxygen simply becomes part of that turbulent sea. Unlike on Earth, where oxygen supports combustion, the sun's extreme heat and pressure prevent any typical chemical reactions. The oxygen atoms don't ignite or explode. Instead, they're absorbed and dispersed by the sun's immense energy and magnetic fields. This means no sudden bursts or new solar phenomena would arise from the oxygen alone. The sun's fusion process, fueled by hydrogen nuclei, remains untouched by this tiny addition of oxygen. So, while oxygen is essential for life on Earth, in the sun's blazing furnace, it's just another particle swept up in the endless dance of plasma and energy. This shows how different the sun's environment is from anything we experience, turning familiar elements into something entirely alien. What about the sun's energy output? So, what about the sun's energy output? Well, the sun's power actually comes from deep within its core, where nuclear fusion transforms hydrogen into helium, releasing immense energy that lights up our entire solar system. This energy output is so vast that honestly, adding Earth's entire supply of water on the sun's surface wouldn't cause any noticeable change at all. The fusion process really depends on conditions in the core, temperatures of around 15 million degrees Celsius and crushing pressure, not on what happens at the surface or in the outer layers. Water, once it's vaporized and broken down, just becomes part of the sun's plasma without affecting the core's reactions. The sun's brightness, heat, and energy output remain steady because they're governed by these internal fusion processes, which are, honestly, far beyond the influence of any external material like Earth's water. So, this means that no matter how much water we pour onto the sun, it won't brighten, dim, or flare up in response. Understanding this really helps us appreciate the incredible stability and power of our star, which just keeps shining brightly, totally unaffected by even the most dramatic additions from our tiny planet. Would this water cause solar phenomena? Solar activity like flares and sunspots might seem like they could be influenced by adding something new to the sun's surface, but Earth's water wouldn't trigger any of these phenomena. These solar events are driven by the sun's complex magnetic fields and plasma dynamics deep within its atmosphere, not by external substances. When water reaches the sun, it's instantly vaporized and broken down into atoms that blend into the plasma without disturbing the magnetic forces at play. The sun's magnetic field lines twist and snap due to internal motions and charged particle flows, causing solar flares and sunspots, processes far removed from any material we might add on the surface. So, pouring all of Earth's water onto the sun wouldn't spark new solar storms or alter existing ones. Instead, the water's atoms would simply become part of the sun's vast, turbulent environment, invisible and insignificant against the backdrop of these powerful magnetic phenomena. This highlights just how dynamic and self-contained the sun's activity is, governed by forces and energies far beyond anything Earth can contribute. Could this water create a visible effect? Any hope of seeing a dramatic splash or cloud when pouring Earth's water onto the sun quickly fades under the star's intense conditions. The water wouldn't linger or create visible effects like steam or mist. Instead, it would be instantly vaporized and broken down into individual atoms, which would then be swept into the sun's seething plasma atmosphere. This process happens so rapidly and thoroughly that no splash, plume, or cloud would form to catch the eye. The sun's surface is a roiling sea of charged particles and magnetic fields, where anything foreign is quickly absorbed and dispersed. So, rather than a spectacular visual, the water's atoms quietly vanish into the sun's fiery environment, becoming part of the endless energetic dance that powers our star. This invisibility of Earth's water on the sun's surface underscores just how extreme and overwhelming the sun's environment is, turning something as familiar as water into an unnoticeable drop in a blazing ocean. Earth's water is precious. Earth's water might seem endless to us, but it's a finite treasure that sustains every form of life on our planet. Losing it all to the sun would mean the complete collapse of ecosystems, agriculture, and human civilization. While it's fascinating to imagine pouring all that water into the sun and watching it vanish, the reality is that Earth's water is irreplaceable and vital. This cosmic thought experiment highlights just how precious and unique our planet's resources are in the vastness of space. The sun, with its immense power and size, remains unaffected by such a small addition. But for Earth, water is the foundation of life, climate, and even our future. Protecting and valuing this resource is crucial because, unlike the sun's endless energy, Earth's water is limited and fragile. So while the idea of sending all our water into the sun sparks curiosity and wonder, it ultimately reminds us to cherish and safeguard the life-giving liquid that makes our world so extraordinary. What other cosmic questions or wild ideas do you want to explore next? Let me know. Thanks for exploring this cosmic journey with Space Facts. If you enjoyed uncovering what would happen if all of Earth's water poured onto the sun, don't forget to hit that subscribe button and ring the bell icon so you never miss an out-of-this-world fact. We love hearing your thoughts, so drop a comment below. What other space mysteries should we dive into next? Keep looking up and stay fascinated. Neptune is spinning through space right now at speeds that would, honestly, obliterate Earth in seconds, hiding secrets so deadly that just knowing them might make you appreciate our fragile blue planet in ways you never imagined. This ice giant doesn't just kill, it transforms matter itself, creating diamond rain while unleashing the fastest winds in our solar system at over 2,100 kilometers per hour. But here's what will blow your mind. If you fell into Neptune, you'd experience the universe's most elaborate death sentence. Do you know what would happen to your body in those final 30 seconds? The freezing journey begins. You're about to experience the most terrifying 30 seconds of your life, and there's absolutely nothing you can do to stop it. The moment you cross into Neptune's atmosphere, your body becomes a science experiment gone horribly wrong. At negative 218 degrees Celsius, the cold doesn't just bite, it instantly crystallizes the moisture in your eyes, turning your tears into tiny ice shards that scratch your corneas. But here's the twisted part. You're still conscious for those first few seconds, feeling every single cell in your body begin to freeze from the outside in. Your skin hardens like plastic wrap left in a freezer, cracking with each desperate breath you try to take. The hydrogen and helium mixture surrounding you offers zero oxygen, so your lungs are already screaming for air that will never come. Your blood starts thickening like syrup, making your heart work overtime just to pump it through your rapidly constricting veins. The atmospheric pressure builds so quickly that your eardrums don't just pop, they implode, sending waves of excruciating pain through your skull. Within 15 seconds, your body temperature has dropped so dramatically that your nervous system begins shutting down, starting with your extremities. Your fingers and toes go completely numb, then your arms and legs follow suit. The last thing you'd feel before losing consciousness completely is the bizarre sensation of your own breath condensing and freezing inside your throat, creating ice crystals that block your airway entirely. Crushing atmospheric pressure. You think Earth's worst hurricanes are terrifying? Neptune laughs at your Category 5 storms while unleashing winds that move at 2,100 kilometers per hour. That's actually faster than the speed of sound itself. These aren't just strong breezes that knock over trees, these are supersonic death machines that would literally rip your body apart at the molecular level. The moment these winds catch you, your skin doesn't just tear, it gets shredded like paper in a blender, peeling away in microscopic strips that get carried away faster than your brain can register the pain. Your clothes disintegrate instantly, followed by layers of muscle and tissue being stripped from your bones in a grotesque spiral pattern. But here's what makes it even more horrifying. These winds are so powerful they create pressure waves that compress and decompress your internal organs repeatedly, like someone squeezing and releasing a stress ball made of your liver and kidneys. Your ribcage flexes beyond its breaking point, snapping ribs like twigs while your lungs collapse and reinflate violently. The wind doesn't just move you, it turns you into a human projectile, slamming you through layers of increasingly dense atmosphere at speeds that would make a bullet jealous. Your bones shatter from the impact forces, creating a cloud of bone fragments that get swept up in the same winds that destroyed you. Within seconds, what was once a human being becomes nothing more than a scattered collection of organic particles, dancing in Neptune's eternal atmospheric fury, forever part of the most violent weather system in our solar system. The methane and hydrogen hell. What if I told you that Neptune literally rains diamonds, and you're about to become part of the most expensive shower in the universe? As you plummet deeper into this ice giant's atmosphere, the extreme pressure and temperature create something that sounds like a fairy tale but is actually your worst nightmare. The methane in Neptune's atmosphere gets compressed so intensely that carbon atoms rearrange themselves into pure diamond crystals, and these aren't tiny specks of glitter. We're talking about diamond chunks the size of hailstones pelting your body at terminal velocity. Each crystal hits you like a bullet made of the hardest substance on Earth, puncturing through whatever frozen remains of your skin still cling to your bones. But here's the truly insane part. These diamonds are forming inside your body too. The methane you've been forced to inhale is crystallizing in your lungs, throat, and stomach, creating razor-sharp diamond fragments that slice through your internal organs from the inside out. Your bloodstream becomes a river of liquid carrying microscopic diamond dust, turning your circulatory system into sandpaper that grinds against your blood vessel walls. The pressure is so immense that any carbon-based molecules in your body, which is basically everything that makes you human, start transforming into diamond structures. Your bones, your muscles, even your DNA begins crystallizing into the most beautiful and deadly gemstones in the solar system. You're not just dying in a diamond rain, you're becoming part of it, transformed into precious stones that will fall through Neptune's atmosphere for eternity. Diamond rain phenomenon. You're about to discover why Neptune's core is the most contradictory place in our solar system. A hellish furnace buried inside a frozen wasteland. After surviving the diamond rain and supersonic winds, you're now descending toward a core that's actually hotter than the surface of the sun itself, reaching temperatures of 5,000 degrees Celsius. This isn't just hot enough to melt steel, it's hot enough to vaporize diamonds instantly, turning those beautiful crystals that were shredding your body into superheated gas. But here's where physics gets absolutely mind-bending. You're simultaneously being crushed by pressure that's millions of times stronger than Earth's atmosphere while being cooked alive by temperatures that could power a small star. Your body, if any recognizable pieces still exist, would undergo a complete phase transition, not just melting, but turning directly from solid to plasma, skipping the liquid state entirely. The core itself is a bizarre mixture of rock, ice, and metallic compounds compressed into a state of matter that doesn't exist anywhere on Earth. The pressure is so intense that water ice becomes as hard as steel, while metals flow like liquids despite the scorching heat. Your atoms don't just separate, they get crushed together so tightly that electrons start behaving in ways that just totally defy normal chemistry. The gravitational forces are pulling you inward with such violence that your molecular structure stretches like taffy before snapping apart completely. You're not just dying, you're being transformed into exotic matter that exists nowhere else in the universe, becoming part of Neptune's mysterious core where, honestly, the laws of physics bend to their absolute breaking point. Wind speeds beyond imagination. Neptune's magnetic field isn't just tilted, it's completely insane, positioned 47 degrees off-center and spinning like a cosmic washing machine that's lost its balance. This isn't your typical planetary magnetosphere that protects life. This is a radiation death trap that's actively trying to cook you from the inside out. As you fall deeper, charged particles start bombarding your body with the intensity of 1,000 X-ray machines firing simultaneously. Your DNA doesn't just get damaged, it gets completely scrambled, with radiation tearing through your cells and rewriting your genetic code in real time like a cosmic computer virus. The magnetic field lines twist and spiral in ways that create pockets of concentrated radiation so intense they would make Chernobyl look like a gentle sunbath. These invisible energy streams slice through whatever remains of your body, ionizing your atoms and turning your blood into a radioactive soup. But here's the truly terrifying part. The magnetic field is constantly shifting and flipping, creating electromagnetic storms that generate electrical currents directly through your nervous system. Your brain gets fried, by electrical surges that are millions of times stronger than a lightning bolt, while your heart tries desperately to beat against electromagnetic interference that's scrambling every electrical signal in your body. The radiation exposure is so severe that your cellular structure begins breaking down at the quantum level, with individual atoms losing electrons and becoming unstable isotopes. You're not just being killed by radiation, you're being transformed into a walking nuclear reaction, with your own body becoming radioactive enough to power a small city. The mysterious core approach. Time itself becomes your enemy, as Neptune's gravity warps reality around you in ways that would make Einstein weep. One day on Neptune lasts 16 Earth hours, but here's the mind-bending part. As you fall deeper into this gravitational monster, time starts moving differently for you compared to anyone watching from Earth. The massive gravitational field creates what scientists call time dilation, meaning every second you experience feels normal to you, but to observers on Earth, you're moving through time like molasses. Your final moments of agony get stretched out across what feels like an eternity to the outside universe. But from your perspective, something even more disturbing happens. Your biological clock starts going haywire as your brain tries to process the changing gravitational forces. The part of your brain that regulates circadian rhythms gets completely scrambled by the intense gravity, making you feel like you're experiencing days and nights that just don't exist. Your body's natural 24-hour cycle becomes meaningless, as Neptune's rapid rotation creates a disorienting strobe effect of light and darkness that happens faster than your brain can adapt to. The gravitational time dilation also means that different parts of your body are literally aging at different rates. Your feet, being closer to Neptune's center, experience time slightly slower than your head. This creates a horrifying biological paradox where your body starts aging unevenly, with cellular processes happening at different speeds throughout your organs. You're not just dying in space and time, you're being torn apart by time itself, experiencing your final moments in a temporal nightmare that defies human comprehension. Magnetic field chaos. You've just crossed the event horizon of your own destruction, the point where Neptune's gravity becomes so overwhelming that even if you had a rocket ship, you couldn't escape. This isn't like jumping off a cliff where you might survive with the right equipment. This is physics saying absolutely not to any hope of rescue. Neptune's escape velocity is 23.5 kilometers per second. That's over 84,000 kilometers per hour. And you're already past the point where that speed is achievable. Your body is now property of this ice giant, claimed by gravitational forces that are 11 times stronger than Earth's. But here's what makes this moment truly terrifying. You can feel your body stretching like a rubber band as the gravity at your feet becomes significantly stronger than the gravity at your head. This process, called spaghettification, doesn't happen gently. It's like being on a medieval torture rack that's operated by the laws of physics themselves. Your spine elongates vertebra by vertebra, creating gaps between your bones that fill with fluid before your nervous system finally gives up trying to send signals through the increasing distance. Your arms and legs stretch until your joints dislocate with audible pops that echo through the thin atmosphere. The gravitational gradient is so steep that your blood starts pooling in your lower extremities, creating a horrifying biological traffic jam as your heart struggles to pump against forces it was never designed to handle. Your internal organs begin shifting position inside your body cavity, sliding toward your feet like contents of a bag being held upside down. There's no coming back from this point. You're committed to becoming part of Neptune's mass, adding your atoms to this cosmic giant forever. Time dilation effects. This is where your existence as a human being officially ends and you become something else entirely. A cloud of subatomic particles scattered through Neptune's atmosphere like cosmic dust. The combination of crushing pressure, extreme temperature, radiation bombardment, and gravitational forces has pushed your molecular structure beyond its absolute breaking point. Your atoms, which have been held together by electromagnetic forces for your entire life, finally surrendered to the overwhelming physics of this alien world. The chemical bonds that make up your DNA, your proteins, your very essence as a living organism, snap apart like overstretched rubber bands. But you know, this isn't a gentle dissolution. It's a violent molecular explosion where every atom in your body gets ripped away from its neighbors and sent flying in different directions at incredible speeds. Your carbon atoms join the methane in Neptune's atmosphere, your oxygen becomes part of the water ice crystals, and your hydrogen merges with the planet's primary atmospheric component. The calcium from your bones gets crushed into exotic crystalline structures that exist nowhere else in the universe, while the iron in your blood becomes part of Neptune's metallic core. What's truly mind-boggling is that your atoms don't just disappear, they become permanent residents of this ice giant, cycling through its atmospheric layers for billions of years. The nitrogen that once carried thoughts through your brain will spend eternity swirling in Neptune's storms, while the phosphorus from your cellular energy systems joins the planet's mysterious chemical processes. You haven't just died, you've been completely integrated into an alien world, your very atoms becoming part of the most distant planet in our solar system. The point of no return. You're experiencing something that no human has ever survived. The complete transformation from a living, breathing person into scattered cosmic particles floating through the most hostile environment in our solar system. Your journey through Neptune's layers has been a masterclass in how the universe can dismantle a human being in the most spectacular and terrifying ways possible. Every single atom that once made up your thoughts, your memories, your dreams, and your fears is now permanently woven into the fabric of this ice giant's atmosphere. The hydrogen that carried oxygen through your bloodstream is now part of Neptune's endless storms, while the carbon that formed your muscles and organs has joined the planet's methane clouds. Your consciousness, that mysterious spark that made you uniquely human, has been extinguished and replaced by pure physics, your atoms following the laws of thermodynamics and quantum mechanics instead of biology and emotion. But here's the strangest part of this cosmic horror story. In a way, you've achieved a form of immortality that no human has ever experienced. Your atoms will circle Neptune for billions of years, participating in diamond rain, supersonic winds, and magnetic field fluctuations, long after Earth itself has been consumed by our dying sun. You've become part of something far larger and more ancient than human civilization, a planetary system that has existed for over 4 billion years and will continue spinning through space long after our species is forgotten. Your death wasn't just an ending, it was a transformation into something eternal, scattered across an alien world at the edge of our solar system. Final molecular disintegration. So there you have it. Falling into Neptune isn't just death, it's the most elaborate and scientifically brutal way the universe could possibly end your existence. From the moment you hit that frozen atmosphere to your final molecular breakdown, you'd experience every conceivable form of cosmic torture that physics has to offer. The freezing temperatures, bone-crushing pressure, diamond rain, supersonic winds, radiation bombardment, gravitational stretching, and complete atomic disintegration would turn your 30-second fall into the most intense and terrifying experience imaginable. But here's what really gets me. Your atoms don't just disappear into nothingness. They become part of Neptune forever, cycling through its storms and participating in phenomena that we're still trying to understand. In a twisted way, falling into Neptune would make you more connected to the cosmos than any human has ever been. You'd literally become part of an alien world, your very essence scattered across a planet that's been spinning at the edge of our solar system since before life existed on Earth. What do you think is the most terrifying part of this journey? The instant freezing, the diamond rain, or the fact that your atoms would be trapped on Neptune for billions of years? Drop your thoughts in the comments below. And if this made you appreciate Earth's atmosphere a little more, hit that like button. Trust me, after learning about Neptune's deadly embrace, you'll never complain about Earth's weather again. And hey, if you want to explore more cosmic nightmares, subscribe because we're just getting started with the universe's most creative ways to end human existence. That's the terrifying reality of Neptune, a cosmic death machine disguised as a beautiful blue planet. Your 30-second journey would rewrite the laws of human survival in the most spectacular way possible. If this cosmic nightmare made you grateful for Earth's gentle atmosphere, smash that like button and let me know in the comments which part shocked you the most. Don't forget to hit the bell icon so you never miss our latest space revelations, and subscribe to Space Facts for more mind-blowing cosmic content that'll change how you see our universe. Until next time, keep looking up.